This is Computing Up, conversations about computation writ large, with Michael Littman and Dave Ackley. This episode was recorded February 8th, 2022.
Hey Dave, how's it going?
Okay, how you doing, Michael?
I'm all right. I'm in Atlanta, Georgia still. How are things in Albuquerque?
Well, we actually got a bunch of snow, and it stayed on the ground for days. Usually snow in Albuquerque is very well behaved. It just comes out for a day and then disappears the next day, so that we have, you'd say we're not California, we have actual snow, but it doesn't really get in the way of things, unlike, say, Santa Fe, where they have snow all winter long. But it's actually stuck around for several days. So it's kind of, winter wonderland.
And is that because of temperatures or because of humidity?
It's mostly because of temperatures. I mean, so far we were good. I mean, apparently you want to have some real cold in the winter to reduce the bugs the following summer. And so it's
I'm in favor
problem,
of that.
Another problem with global warming.
Bugs.
Yeah.
From their perspective, I guess it's not a problem at all.
Yeah, I just don't take their perspective all that often.
No, that's fair. You want to get rid of bugs in your code and in your house.
Yeah, absolutely. It's funny, bugs don't even see houses, It's just like, it's all just space to them. Yeah. And if it's some space that's a little bit easier to get to than others, well, then so be it. But if somebody's not defending there continuously, eventually it's all just space.
They're going to get in. Well, it's interesting because, so we're having some bug issues here in our rental place in Atlanta, it's been very unpleasant. And I'm told that Georgia has bugs, and that's just a thing. And as you say, like they don't know, they don't care. But people are telling us, the kind of bug that you have, they can't breed indoors. And I'm thinking, does that mean I should invite them in to cancel out future generations? I don't understand what to do with that information.
Right. I guess it just means that they're going to go back outside. So they're not really living with you. They're just coming to visit. Like that, looking for snacks.
I see. So that's a small comfort then, I guess, is the intent there.
I guess rather than having a nest in the house with you or something.
Right. Let me introduce our guest for today. So we don't have a guest for today. I just thought it would be really good to get a chance to talk with you a bit more and keep you to myself to hear about some of the stuff you've been thinking about cognition and computation and life and whatnot. Specifically, I've seen on some of your other videos this symbol that looks to me like the artist that used to be known as Prince's symbol. It's got like an arrow and a loop and stuff. And I was wondering if you could kind of take me through that and help me.
Sure. Thank you. Sure. I don't know where to begin. Well, I call it the self-image and the self-image. And the idea is, there's a lot of ways to look at the world. There's a lot of ways to look at the big picture of everything. And like physics says, it's all physics. And, neuroscience says it's all in your neurons. If you want to understand like consciousness and free will and who we are and all that, there are people that'll tell you it's in your neurons. It's all physics. It's all biology. It's all
chemistry.
The mind of God. Chemistry. Okay. It's all in the mind of God. Whatever. It's all in interpersonal relationships. There's a million different things that you could take to say this is where I should begin. This is a place to anchor my theory of reality, my theory of other people, my theory of my own mind, and so on. And, so I've been thinking about that all my life, like thoughtful people do, to think, how can I make sense of everything that's happening around me and inside me and of myself? And because, this is computing up, right? Our mandate is computation writ large.
Right.
And so part of that for me is trying to have a computational story of people and society and so on. And so coming from that point of view, I end up thinking that what it really comes down to is you and I, everybody listening, are a certain kind of machine, a certain class of machine, that's crucially, we are programmable machines, and programmability implies a programming language, that it's possible to send a message that will cause the machine to behave differently because it's got new programming now. And so then to me, the question becomes, all right, what kind of machine are we? And in a way, that just recapitulates what we were just saying. We say, oh, we're a machine made out of physics. We're a machine made out of atoms. We're a machine made out of cells, out of neurons, whatever it is, like that. And people do that all the time. The mechanistic view of the universe is a largely popular one, and everybody has their own take on it, or at least within the sciences, within the physical sciences, physicists are happy to tell you it's all about physics, and neuroscientists are happy to tell you it's all about neurons. But that all seemed a little bit unsatisfying to me,
because it's not all about computation.
Well, that's yes, exactly. So this is my turn because we're computer scientists, so we have to say it's all about computation. And so that means how are we going to talk about it? How are we going to say it's all about computation? And people like neural networks people that do neural networks research, the very phrase neural network is making an appeal to a kind of computation that is somehow something like a neuron, the same root word, and so on. And there's all other kinds of computational models that are more physics or chemistry, whatever it happens to be. But to me, and certainly you and I both have done neural networks research over the years. And I got to the point where that all seemed a little unsatisfying, that it seemed like it really wasn't that important, that it was strictly about neurons. There would be lots of other ways that you could do it. Maybe it's just about matrix multiplications or whatever it is. And so if it's not, and that coming at it from the basis of neurons, seemed to me like trying to understand a computer by thinking about it solely in terms of voltage levels or transistors or something like that. It's not that it's wrong. A regular computer is made out of transistors, but it's not like you're going to get that useful a predictive model about what that machine is going to do if you just look at transistors and voltage levels and so on, like that.
Right. So now where do you come down then on things like, I don't know, I feel like there was an XKCD that dealt with this, but I also feel like you and I back in your office a zillion years ago talked about this stuff where it's like, well, what is physics, chemistry, biology, economics, sociology, and so on up the chain. If they all are just physics at the end of the day, then why do we even have these other things? And these are just really convenient levels of description in some sense, right? Is this what you're getting at with this predictive model?
Well, I mean, yeah, I guess so. I mean, there's one sense in which I am okay. So physics wants to say it's primal because, it's the smallest, the earliest, the whatever, the proto-protons and the Big Bang origin of the universe.
Right, but then the XKCD says then the mathematicians pop in and they're like, yeah, and you wouldn't even be able to talk about what you're doing without building on what we have.
Right. And then computationalists pop in and say, you frickin' mathematicians, you are just a mere specific programming language. Mathematics is just merely a programming language, one of zillions of programming languages. And in fact, it's a limited and esoteric and nerd out one that is of much less importance of many, many things than other kinds of programming languages, like, for example, natural language. And what that highlights is that
linguists are really at the bottom.
when people talk about physics being primal, they're trying to talk about reality. They're trying to talk about what's out there. But in reality, physics is a code base. It's a bunch of language that people can use to talk to each other and say the pendulum goes left and right and the energy is conserved and it moves downhill. That's all a bunch of language.
All right, hang on. You just made a move that I think might have lost me, maybe if not me, others.
No, that's what I want.
So physics, when people say physics, I think they mean physics. I think they mean, like matter and energy, like the things that physics talks about. But you made a move to switch to say, no, physics is the talking about. It's not the world.
Thank you. Yes, absolutely. And that is, I want to hit on that shift over and over and over again. And that we want to say we are talking about reality out there. No, I'm not talking about the word physics. I am talking about the actual reality out there, like that. And people say, okay, that's fine. But you're not actually talking about the reality out there, because what can you say? I'm looking at a monitor with a picture of Michael on it and a microphone and all that stuff. And physics didn't tell me any of that. Physics can't tell me any of that. Physics only can tell me stuff in general, like it's all made out of quarks and energy particles and so forth, like that, which is not an actual thing. That is now a description. That is now an equivalence class saying that everything is made out of quarks or whatever it happens to be. So yes, and that's the shift I want to make. And that's the shift that everybody who says it's all physics or it's all neurons or it's all the mind of God or whatever it is wants to resist. They don't want to go from, no. I'm not talking about talking. I am talking about it. I'm talking about the real thing, like that. And the response is, yeah, but you're talking. So what's actually going on?
I got really shredded. Hopefully this will never get back to the person involved, but a senior faculty member recently retired in my department. I told him that philosophically, I consider myself a radical Boxist.
Right.
And Box was a statistician, and he has a quote that shows up in a lot of machine learning talks, which is probably the only reason I'd even know about him, which is all models are wrong, but some are useful. So a radical Boxist says all models are wrong, but some are useful. Right. Yeah. And so this notion that they're all models, none of them are actually reality, but some actually are more relevant or more practical, more useful than others. And he got so mad at me. He said, "You're basically Trump," which coming out of his mouth was definitely an insult. He didn't mean it in any kind of positive way. That all the bad things in the world are happening because of me and people like me for having those thoughts. Yeah. And I think he was very much resisting, as you're saying, this kind of peeling apart the reality is what it is. We're talking about it, and there's different ways of talking about it, and there's better and worse ways of talking about it. And he's like, well, as soon as you make that move, that means they're all equally good ways of talking about it. And that means anybody can say anything they want. Cats and dogs living together, the world completely falls apart.
That's right. And that's where he was wrong. That there are people who are terrified of leaving the land of truth and the land of actual truth, because they want the land of actual truth to be real, to be physical, so desperately that the self circling around is built out of it, like that. And so, from the point of view of saying, no, I have constructed my life on mathematics and physics and the pursuit of ever greater truth, that anybody who's going to try to make room to say, no, there are degrees of truth, no, a certain amount of untruth is okay, needs to be shunned. Now, just like we were talking about last month with Fiery Cushman, that morality is not just something you know, but something you need to enforce on other people. And so this idea of, everything is just a model, and models have areas where they work well and areas where they don't work so well, it's very threatening to that truth. There is the one truth framework that we're all trying to elaborate. And if you let any cracks come in there, then you're dead.
That was a really good description, because at the time I felt very, very attacked, because I wasn't saying anything that I thought was all that radical, though I guess I did use the word radical in radical boxes. But he put me in the unclean category, right?
Right. That's
with right. I guess, maybe this would have been a helpful at the time. I just thought, this guy's a terrible person and I hate him. I'm never speaking to him again, which, by the way, I've successfully done.
Well done.
Yeah, you're welcome. But at the same time, I didn't understand what he was finding so upsetting. And I think what you're saying is that if you admit that your model is just one of many, then you have to defend it.
Yes.
And it's so much work, right? It just makes everything up for discussion. And who needs that life?
It would be so much easier if you could just shout down every competing model and say, but you're not physics or whatever it is. You're not part of the grand edifice of truth that we have built since the Renaissance in the West. And, the sort of standard vision of science as the search for ever greater truth, and that truth is real and truth exists, and all of the little niggling edge cases where physics starts to not work quite so well, like, the wave particle kind of thing, and the sort of observer thing, where it seems kind of like how you come at the world can actually affect your description of the world, your observation of the world, which means you cannot actually get outside it, which means it cannot quite be an objective truth separate from you. So that's that's one problem. And there's other problems, like the sort of computational incompleteness, the fact that a system can't completely prove everything that's inside itself. There's all kinds of these little edge problems, but people who are invested in it, they want to shout, they want to just dismiss all that. That's not important. Self-reference doesn't come up very often. It's the backbone of what conscious experience means. Is all about self-reference. But in any event, there it is. And so I want to say we need to figure out a way to force that shift, that physics is not about the world out there. Physics is a set of descriptions, a set of languages, a set of code that we share with each other, that allows people to do experiments and predict their outcome. And in a fantastic array of environments, it's very predictive. It's physics writ large, which now includes the better behaved parts of chemistry and all these other stuff that are all in there. I'm roping all of that in as being this amazing code base that we teach each other, and we use to build other machines that, technology, rockets to Mars, so on and so forth, all using that, despite the fact that there are cases where it doesn't work, and there are cases where it can't work because of self-referential reasons or incomputability reasons or whatever it is. And that's all fine. But we have to accept that first it's code, first it's language. And that puts it in the same bucket as Trump's big lie, or whatever other language you want to shun. Like that there cannot be a categorical, this language is pure with God and everything else is Satan, like that. We have to fight the ground war step by step.
Right. This notion of thinking of something like science as a code base. I mean, first of all, that's a crazy way of saying it. So that's awesome. But But it does resonate with something that I've been thinking about a lot lately, which is that grad school is prior construction, right? That basically what a scientist is a walking prior, right? A walking thing that says these are the kind of descriptions that we talk about that have high probability. These are the kinds of descriptions that we don't, and they're not clear and a priori. You're not born with those. You have to join the culture. You have to join that community and learn what the prior is, because otherwise you can't communicate with the rest of that community. If you want to be a scientist, you have to talk their language.
Science, and absolutely.
Right. And it varies from community to community too. So even with computer science is different than the way that, that chemists talk about things, but even within computer science, what an AI person would accept as a reasonable level of description, like a theoretician might not like, and a systems person might not like. You can't, it's not just, you're not born with that. You have to absorb it from going to conferences, reading papers, talking to people until you kind of become one with that prior, and then you're part of the community and you can contribute.
Absolutely. And, you're a big professor, so a lot of your interactions is with grad students. But from my point of view, there's nothing special about grad school as far as creating a prior creature. We're deploying code on young scientists. We're making them scientists by deploying all these priors. But that's the same thing that's going on in elementary school, in kindergarten, in church, around the dinner table every damn night, to make someone be a human, or to make someone be a Christian, or to make someone be an American public school kid, or whatever it happens to be like that. There's nothing special where now the priors kick in grad school. It's just, right. That's the experience.
Yeah. I mean, the reason why it feels special is because I think our prior that we come in with is one that says science is just this is reality, and we're just learning about reality, when in fact, right. I think the surprising thing is, no, actually you're learning to be in a community, that it is like those other things.
Yes. And there's a bunch of stuff that goes into being a member of that community, or as I would say, being able to run that code. And so part of it is how should you see things? Which things are things versus which is just noise and in mistakes and irrelevant. And part of it is, how do you actually do stuff? So how do you write a paper? What's the first step, and then the second step, and then so on? How does it all go through? And one thing is, how do you judge quality? How do you judge what's good and what's bad? How do you acquire taste in research problems, for example? That seems like, it's kind of hard, computer science 302, taste in research problems like that. It's 12 weeks. There'll be a quiz every week,
There's just like little glasses of research problems. You take a sip and you swoosh it around and you're like, there's a little bit of
I see. There. Yes. Kind of a lot, very math forward, but, a lot of late for physics, am I getting cat pee? Whatever. So the idea is that recapitulates no matter what your discipline is. You've got these questions about how should you see things, what even are things and what aren't, and how do you do things step by step? What should you expect the results to be? What is the set of results that you can expect, and how do you decide whether something's better than another thing like that? And that set of processes, how do you see things? How do you predict what's coming next? How do you do a sequence of actions? How do you decide what quality is? That seems to me to come up over and over and over again, no matter what your discipline is, even if it's science or being a member of the church or shooting squirrels in the backyard, whatever it is. There's a set of things. What's important,
for what it's worth, it is the official stance of computing up that you should probably not do that.
Yeah, shooting squirrels. Well, I mean, whatever. And
So much for it being an official. It's like, no, you do you. You have a squirrel problem. Go nuts. What can I say?
Well, hey, if you're going to make squirrel stew, you need some squirrels. You got to get them someplace. The supermarket might be out. So what I wanted to do is maybe we should organize our understanding of ourselves around those processes, around how to see things, how to predict things, how to actually take steps in the world, and how to judge quality. And that is the purpose of the self-image that we started talking about. That is the purpose of that symbol that looks like Prince's name before he got his records back, or whatever it was, the fight that he had with the record company. It looks kind of like a person. It's got two arms, kind of a leg thing, and a loop kind of head thing. And we'll put it in the title card for this episode. Will be the self-image, so people will see it right up front. So arm.
Okay.
Go ahead.
Yeah. Well,
I'm just my immediate reaction. Mapping.
So see, predict, and then I think at one point you said do, but another point you said steps. I don't know what. Do you have a favorite word for that?
Well, I mean, I got actions. I got action. Okay. So and then judgment,
and then decide or judge.
Judge quality, good or bad.
Okay, and because it feels a lot like the classic reinforcement learning picture that many of us have at the beginning of our dissertations. That I stole mine from my advisor, and I don't know where she got hers. But
what does it look like? What does that picture look like?
So, all right. So there's the agent, which is a box, and then there's the world, which is a box. And the world sends information to the agent. That's its perception, which I would say as what you would call C. Right. And then that agent box issues actions at the world. And so that's like the actions that you have. It goes back up to the world. Yep. Then there's often a second, depends, different pictures draw this a different way, but the classic one, the world also issues rewards, which are a kind of evaluation or judgments about how good things are. Right. And then inside the box is some kind of computation that's deciding, okay, well, how do I pick the action so as to maximize the reward? And so it has that kind of predict-ish aspect to it as well, that we're trying to decide. Though built into it is the idea that we're not just deciding, we're deciding to maximize that reward signal. That's our goal in life. Right.
Well, that's why the idea of quality and judgment actually has some bite, because it affects what actions you choose. And hopefully it affects them in a way that leads to more reward or whatever it is. Or if it doesn't, hopefully the reinforcement learning creature will do different stuff until hopefully it does find something that leads to happiness and reward in that sense.
So are you thinking that these are just this two ways of writing the same thing, or do you see the self-image as actually occupying a kind of a different role?
I think what you described is one particular machine or one particular class of machines that fits very naturally into the broader family of self-image, of machines that are in the self-image family. And the things that are specific to what you just described is the judgment comes from outside, which isn't necessarily the case. And the computation that happens inside, the sequencing that happens inside the box, take the input, run it through here, max it there, do a soft max here, pick the thing, whatever it is. Those internal steps, separate from the actions that we do out in the world, go left, go right, like that, those are fixed. Those are not changeable. The steps that happen internally, the internal sequence of steps is fixed. And that's the research that you do, is you make up a bunch of steps that will say, okay, if we've configured this, physical machine this way, and we do this sequence of steps, then, look, it's doing reinforcement learning, like that. In the more general self-image model, that sequence, what actually happens between the actual sensory data coming in and the actions taking place is itself reprogrammable. Because we can deliver code that's going to affect those sequence of steps like that. And so different research areas in many ways differ by what they nail down, what they make not programmable like that. And that's all fine. That's great. It still means that your reinforcement learning machine, your figure one of your dissertation, is absolutely an example, is absolutely an instance of a self-image kind of framework. But it's a specific one that you've nailed a whole bunch of stuff down and say, I'm not even going to think about changing that stuff because it's too general and there's a lot to learn even if we nail this stuff down.
So, okay, then, but you're trying to pick a level of generality that's somewhere between that and, well, it's just computation, right? It's just input output. Because you have, I don't know, I guess C is kind of input, action's kind of output, but predict and decide, judge, isn't that just all computation?
Right. Yes. And thank you for bringing up the objection because it's an absolutely fundamental one. Traditional computation says, input, output. Yeah, obviously, computation has to have some input, has to have some output, or it can't possibly be useful. It has to take some steps, some sequential steps to get from input to output. So, okay, there's sequence, but who the hell needs judge? What does that actually accomplish that we can't just say is just computation? And my answer is that, we talk about heuristics. We talk about search processes like that, where, in fact, even when we are the programmer, we don't specifically, completely, exactly know how the computation is going to unfold step by step, because it's going to use a pseudo random number generator, or who knows, it'll use a real random number generator if that's somehow different, to decide what thing to search next and so forth. And we don't know or care exactly what the details are there. We just hope that it'll find something that's useful to us. It'll achieve something that we can use. But the instant we do that, the instant we give away, micromanaging the physical system all the way down to the bottom there, then judge becomes a real thing, because now that system has to make the step and say, okay, does this achieve the goal that the guy told me? Well, no, it doesn't. But which way should I go? Should I make it more like this, or should I make it more like that? He didn't really tell me. He doesn't really care. He just needs this good enough like that. So when we start to use algorithms that are heuristic, not guaranteed to work, we start to use computations that are not deterministic, that they may go one way or the other and we don't really care, then quality judgment becomes a real thing. Now the machine has a certain amount of agency. The machine has a certain amount of authority. I'm going to decide doing this. I'm going to try this one again. Because I think the function might not be deterministic. If I evaluate the same thing twice, it might change, or whatever it is. And so we can try to write that out. We can try to say, no, I gave you a random number generator. We're going to use linear feedback, shift register, whatever. I gave you the seed. It's 1. So now, even though I don't strictly care, you have no agency anymore. Now it's completely determined like that. Mm-hmm. And you can do that, but it's uninteresting, and it becomes more and more and more uninteresting the bigger the problems you're trying to face like that, especially because the bigger the problems you're trying to compute, eventually you can't even be sure the machine didn't screw up and get something a little bit wrong and keep on running, so that even if you did start with a C to 1 and it should have gotten the exact same answer this other machine you might not. People claim they care about it being deterministic and being absolutely correct and so forth, but it's a lie. They really just want an answer that they can use. And if they can take that answer and run with it and, publish a paper or make money, they're fine like that. And so that's why as soon as we allow the machine, the running machine, that we said, I would like you to optimize this thing, please let me know once you've achieved a score of 100 or better, that machine now has a certain degree of authority, a certain degree of agency, a certain degree of ability to make decisions of its own. And that's why judge is a first-class citizen in the self-image model.
Interesting. So now you said a lot of words that made me think that you were going to say free will at one point. And I don't know if you carefully avoided saying that or if you're not making that connection, but this notion that the machine has agency and has authority feels very much like it has free will.
Yeah. I avoid the word just because it seems so fraught with, it leads people off in philosophical conundrums and paradoxes, which I don't think are fruitful. So I prefer to have other folks bring it up rather than me anchoring it on there. But I think it's absolutely right. It's an absolutely good point that the more we give authority over to our machines and say, here, I'm just going to describe generally what I think is desirable. I'll just describe generally what I'm looking for. And then, surprise me. Right? I mean, we say that to people all the time. We say, I'm looking for something that blah, 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 surprise me. Like I say, the waiter, what do you want to eat tonight? And you say, surprise me. Like that, that's explicitly giving
literally
authority.
Never say that, but okay.
Yeah, well, I
don't like, and I when I was young, I thought I desperately wanted a surprise party. And then my mom threw me a surprise party and I hated it so much that ever since then, I'm like, do not surprise me. But no, I understand what you're saying though, because if I do ask the waiter for a suggestion, I don't just say surprise me, like bring whatever. But the waiter is certainly going to surprise me with a suggestion, because if I wasn't going to be surprised, then I didn't need to ask at all.
Right. So if you knew what it was going to be.
Yeah.
Exactly. Yeah. And so, I went to an extremely expensive restaurant once, and the waiter, it was all great and super everything. And the waiter said, at the beginning of the meal, are there any ingredients that we should avoid? And I said, or any ingredients that you don't like or something like that. And I said, maximize surprise, like that. So there's nothing's off the bar. Just delight me, surprise me, like that. So that's the idea of giving away a ton of authority. Mm-hmm. Like, you could bring me a cup of arsenic and I would go, oh, that's a very nice year. Oh, that's very nice. I said, you're such an expensive restaurant. You must know well enough that this is something that I should go ahead and drink, like that. Yeah. And so, it's a separate discussion that I don't necessarily want to go down into. But even when we think about writing a random number generator, where we're going to do search, we're going to pick choices at random. What does random really mean, except giving authority to something else to decide what to try next, like that, giving it to X-ray quantum breakdowns, or giving it over to keystrokes and disk interrupt timings and stuff like that. It means we're giving up authority to decide what comes next, and claiming that the thing that we're giving it to, physics or whatever, is going to do a fair job, like that. We don't actually know. We just assume it, like that. Anyway. So, all right. So where the hell are we now?
Okay. So this is where I am at the moment. So I have this sort of picture in my head, which is similar to, but maybe not exactly the same as the standard agent picture in AI. I think it's in like the first chapter of the Russell Norvig AI textbook, for example.
Sure.
And, but one of the senses that I get from the way that you talk about it, that comes up in like chapter 5 or whatever, like down the line, is a sort of notion that that architecture shows up at multiple levels, right? It's not just you build the agent that way and you're done. It's that inside the agent, other decisions and observations and judgments are being made. And so you have this kind of recursive self-image, as it were. Right. And is that seems to be an important part of your story? Yes.
Yes, it absolutely is. We haven't talked about it yet. But so the big picture is, it's about programmable machines. It's about machines that we can send something that's going to pass for code too. We're going to pass for programming language that we're going to send to this machine, and it's going to be able to, it's going to behave differently because we sent blah, 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 blah code rather than blah, 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 blah code, like that. And that machine that we're going to characterize in terms of input, output, sequence, and judge, is going to be useful to us. Not to put too fine a point on it. We're going to send some code out in the world, and we're going to make a profit by whatever we consider profit to be, whether that means money or the cats giving us dinner. The monkey owners giving us cats dinner because we went meow, or whatever it happens to be.
I lost you on that one.
Sorry, I was taking
owner giving a cat dinner.
Yeah, so the cats, our cats, look at us as these big monkey owners. They're these big incompetent servants that they have to constantly go, hey, monkey owner, it's dinner time. And then finally we get it, and we give them their due, like that. So they're using this programming mechanism, like that. It's stochastic, but hey, programming code doesn't have to work guaranteed in order to be code. We can send it out there and hope that the machine will run it. It's the machine that hears it. Maybe it does, maybe it doesn't. But hey, as long as we shift the odds, or as long as we happen to observe that seems like, hey, I meowed 15 times and then I got food. So I'm going with the meow is the important part of it. Like that. I'll meow up to 16 times next time, or whatever it is. So, yes. So I'm saying it's about code. It's about code it's about us trying to code other machines. It's us trying to program the world to do something that'll be good for us, do something that'll turn a profit for us, give us a hamburger, avoid getting hit by the car, or whatever it happens to be. And a second question is, okay, how is that machine going to do it? How are we going to actually implement a machine that's going to be able to take this high level language, like surprise me, make a delicious dish that surprises me. And it's going to turn out that the only way that we can do it in the long run is by making it out of a bunch of smaller machines that have input, output, sequence, and judge in them as well. So that's the sense in which it's going to turn out there's more than one, because a machine is a simple machine. I mean, a simple machine, a simple machine can't do really much of anything. I mean, even really teeny tiny little, a single transistor can be viewed as this super simple little machine where the programming language is the amount of voltage you apply to the gate, and it can only make this one routing decision, essentially. But then we can go up to more and more complicated things and nest them like that. So what I'm saying we want is, well, okay, couldn't we take this stuff and describe it all in terms of physics? Couldn't we take all this stuff and describe it in terms of chemistry, biology, whatever it is? And the answer is yes, we could. But we probably do better to understand the commonality among all of those machines, to analyze it in terms of input, output, sequence, and judge. That is the idea. So the self-image is just trying to make it as simple and memorable as possible, to say this is one way to analyze, to understand what's going. It's one way to see. It's one way to predict. It's one way to judge. It's one way to do. It's one way to do output like that. So yeah, to say, oh, well, now you're getting much more complicated because now there's all selves inside selves. It's turtles all the way down, like that. And the answer is, yeah.
It's society of minds all the way down or something.
It's, very much so. Very much in the society of mind spirit, like that. Not because it is, but because that's a good way to describe it. It's a good way to understand it. See, I don't want to make the mistake of saying, no, I'm talking about what is, unlike all those physicists who thought they were talking about what is. And I said, no, haha, you're merely talking code, like that. Always got to remember, we're still talking about code too. So we're saying, should we say a human as an example of a reinforcement learning agent is one of these things? Is that true? Is that real? And that's the wrong question. The question is for many, many purposes, we can understand, we can make money, we can make profit by treating a human as if they are an integrated one of these self-image models, even if for certain purposes we would want to drill inside and find the society of smaller self-images that go into their thinking or go into their physical being or makeup, whatever it happens to be.
So that leaves me in a place of feeling like base case. Like I want a base case. I want at some point the recursion has to stop. It can't be turtles all the way down because we don't have an infinite supply. So was that what you were saying about the transistor? Like at some point it does become physics or something? Like on the one hand, I want to, yes, on the one hand, it's like physics or some like the whole thermostat thing seems, the thermostat's got judgment, too hot, too cold. It's got actions, turn the furnace on and off. It's got sensors, determine the temperature and all that. So that's a canonical sort of base case. But I want to push back on the desire to find that kind of recursion. Because that's what ends up leading us down to protons and subatomic quarks, and ends up leading us back to the Big Bang theory at the beginning of time, to try to imagine it that way, as opposed to say the base case is you want to have a hamburger. The base case is natural language that we exchange between people. The base case is look out as something is going to hit the person that I'm talking to, like that. And the way we might as well understand it is there's this world full of machines out there. Where did they come from? They came from the ancestors. They came from other machines that used to be out there, because that's what life does. But the important point is there's a bunch of machines out there. They are programmable in certain ways. They have a huge, unbelievably complex code base that's running on each of them. That's slightly unique in each individual case, but shares tremendous commonalities between them. And how can we deploy code on that population of machines that are out there? That's the base case. That's where it really begins. That's where, we're coders, we're looking at the world, we see these self-image machines out there, and we wonder, will this code run on them? Will they be able to get it? Will they be able to get the self-image? And that's why I've been so consumed with trying to find the simplest, shortest, most iconic bit of language, visual image, songs, puns, colors, everything, to be the sort of calling cards for this API, this idea that the one way we need to be able to look at us is as computational creatures. We are programmable machines. We are coders trying to code on each other, and increasingly on non-human machines, on silicon, on training animals, whatever it happens to be. One thing I like about the code base, I'm going to call it an analogy, right? Because it's this, like as you're describing, it's kind of a concept that if you accept this as a description, or if you use this as a way of understanding the world around you, it provides certain affordances, right? There's certain things that make it easier or harder to think about as a result of viewing others as being these machines that are running a code base. And one of the things that I think is nice about that is, like, I want to say one case is like, well, okay, we're sending code and then the other things are running the code. Here's two extremes. One is like, okay, here's a rock, and the code that it runs is like, you can you can hit it and it'll move, but you can't it's not a Turing equivalent programming language, right? It's a very, very, very constrained set of things that it responds to.
Yes.
And so that's one extreme. And another extreme is like, oh, well, it is just a computer that is just accepting code and just going to run that code, which also doesn't feel very like that. The rock doesn't feel very self-reflective. And a computer doesn't feel very self-reflective. It's so general that you literally give it the code and it runs the code. And maybe people like things are in this in-between zone where they'll react sort of reflexively to some things, but you can get more complicated behavior out of them, programmatic sort of behavior out of them. But it's not as simple as just like you hand them the code and then they run it. You have to kind of coax them into it. Why? Because they're running a code base, right? They already have a bunch of things built into them that's going to cause them to behave a certain way. And you have to kind of work your way through that to get to the ability to change the behavior in some way that you desire.
Yes, that's great. So every person is somewhere on the spectrum between a Turing complete computer and a rock, and in immovable rock. If you want the rock to move an inch, you have to do all the work, invest all the energy that it actually takes to move that rock 1 inch. That rock has got no separate source of power that you might be able to switch, that you might be able to get some other source of power to move that rock for you, like that. And humans are somewhere in between. Certainly you try to have an argument with somebody and they can be like a rock. They will not move. They will not grant your position, even hypothetically, because that's the way they are. Whereas at the other extreme, a toddler that's just starting to learn language, they will believe just about anything you tell them, anything that they can understand. You can tell them to walk off the staircase and they may well walk off the staircase at least once. And it's your fault for being a jerk. Like that.
This is why it was useful for us to have had 2 kids, because one of them was very much in that category and the other one was very much not.
That's right.
One wouldn't do it. Even if I gave a really, I'd have to give a really good reason and she would have to think, yeah, I see where you're coming from and I accept your premise. Whereas the other one was like, sure, that sounds totally reasonable to me.
Yes. And so, I think it's a good way that you can understand people as varying on a spectrum of how much they need to protect their agency, how much they need to. I will not do something unless I can understand why it makes sense for me, like that. Whereas other folks are much more game. And they'll say, hey, I trust you. So if you say do this, let's do it and we'll find out. And, there's no saying one strategy is always better than the other. In fact, they're both right and both wrong, depending on circumstances. It's just they program in different ways, like that.
So maybe now we're ready for me to ask the question that I've wanted to ask from the beginning, but I didn't know that I'd understand the answer, which is there a relation between your choice of the word self-image machine and what we think of as our self-image? Like the kind of the common use of that phrase. Is that just a coincidence or is there a deeper connection there?
Well, I think when people say, I have a self-image, I think of myself in a certain way. I think there is this computational layer to that self-image that people don't think about. They take it for granted that I am a input, output, action. I am an input, output, sequence, judge machine. They take that for granted and they focus on the details. I'm an aesthetic. I'm sensitive to colors, or I am good with my hands, or I have a great sense of aesthetics. I can judge beauty or whatever it happens to be, all of which can be framed in terms of, okay, that's the input stuff you're talking about. That's the output stuff. That's the sequence stuff. That's the judge stuff, like that normally just goes without saying when people think of their own self-image. And I'm saying, let's make it explicit. Let's pull those 4 basic processes: perception, action, internal sequencing, taking steps all inside the machine, and judging whether a situation or whether it be a current actual perception or a hypothetical perception that was produced by internal sequencing, whether we like it or not, like that. We should bring those forward as first-class concepts, and that will then enrich what people think of as their a priori notion, their naive notion of a self-image.
Nice. Well, thank you for taking me through this. This is a journey of self-reflection.
And I really think that it's worthwhile. There's stuff there that when people can get in misunderstandings and arguments, that they might be able to get out of them quicker if they could say, I see. Well, your category, you're seeing it differently because, you've got blah, blah, blah. Or we're seeing it differently, but you're thinking that the next step is blah, 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 like that. So the goal is to say, couldn't we come up with a common language? It's not the only language. You can still talk in terms of physics. You can still talk in terms of neurons, but you can also talk in terms of these computational processes: input, output, sequence, judge, without having to implement them, without having to be pushed back to programs and photons and protons and electrical voltage levels. We can have that discussion at the level of computation, at the level of code.
All right. Fantastic. Well, maybe in a future episode, we can kind of take something from life, like a political debate or something like that, and try to see how to cut through it using some of these ideas.
Yeah, that would be great. Well, Michael, thank you so much for pulling on the ideas, because, my head is so full of them, and I never know where to begin. So I need someone to give me places to begin, and then we can walk together. Hopefully, folks will help get this, and we'll see.
Well, fantastic. Thanks again.
This was Computing Up. Thanks for listening.